on this thing right now where I'm trying to see if I can pocket people, so I was trying to see what you had. You suck.
That's why you're touching my pockets.
Were they intersect?
You're not very good at pickpocketing.
Yeah, you're very bad at that.
Yeah, he like came with it like
I did
basically most of
You
it.
are not slick at all.
No, okay, you went over there and went like this.
Okay, y'all got your,
She did this with them.
y'all have your
She
five,
did this with them.
What?
your five intersect, second trace, intersection.
Hold on. What? Alright. You don't remember doing this yesterday?
Enter, enter, enter.
I
So
do.
x1 is negative 2.094. I'm gonna write them out here to the side so I can see them.
No shitting.
This,
Wait, already put my deck with wire.
Okay.
Staying up
whenever you get the curve for the line, and then.
Did you know that is?
Yeah.
Yeah.
That's
Interesting.
He's got like hair right, and it's
We
like
thought
a
maybe
dark
they
color.
did it too long.
Well, everyone has to.
Well, not everyone.
So, Brian, what is the cure to depression?
Negative, but I wouldn't even try.
Not sure if I'm aware.
What is that one?
Treatment.
I said I was thinking
Las
this, I
Vegas.
don't know why.
You're on it.
You might have
How do you
put
get
it in
more
the right
ready?
one, because you have to do zoom out slot 7. Put in perfect.
No, he's not.
You might have forgot to do that.
He's going to do.
Or you might have had it in degree.
All right. So I have these as my x1, 2, 3, and 4, and 5 values. So what we were doing yesterday on the trigonometric technology thing, remember we were finding the relationship between them because the goal here is to be able to solve for all the solutions. And while I can see 5 of the solutions in this window or on this graph, I know that both the curve and the line go on and on forever. So what we were figuring out yesterday was if I know the relationship between these two dots, and then I know how often something repeats itself, I can just find the next 2 and the next 2 and the next 2 and the next 2. Obviously, with a calculator, that's pretty easy to do, but one of the problems with the calculator is that what we're getting when we do that is what we call approximate answers. Those are rounded decimal answers, and we don't necessarily always want that. A lot of times we would prefer to have exact answers, which we get off of the unit circle. So we have another method of doing it besides using a calculator, and that is going to be algebraically. So we're going to solve for x. So I need to get x by itself, just like always in algebra, getting x by itself. So I need to get rid of the word cosine. How do you get rid of cosine?
Inverse cosine.
Inverse cosine. So I'm going to inverse cosine both sides, or cosine to the negative 1. And so that's what they have written here. X equals inverse cosine of negative 1. So I need to know what reference angle is cosine equal to a half. So those of you who are good with the left-hand trick, great. If you're not, maybe today we can get you a little better at it. I'm going to use my left hand to figure out where cosine is equal to a half. So the number on top tells me how many fingers I need to be looking for. Cosine is the x value, so I need to be looking for 1 finger on top. So my thumb counts as a finger. So if that's 1 finger on top, then I fold in this finger to separate my ordered pair. So now I have x's and y's. Well, this is all that I'm concerned about. So then I just figure out, well, what finger did I fold in? So what finger is that in the left hand? 3. It's pi over 3. So remember, those of you who know baseball, it's 6, 4, 3 double play. 6, 4, 3, 2. Those are your denominators. So I folded in the pi 3 finger, so that's my reference angle, pi over 3. But cosine is not negative in quadrant 1. So it asks me, where is cosine negative? Where's cosine negative? Second.
Third.
Quadrant 2 and quadrant 3. So I need the pi over 3 that lies in quadrant 2 and quadrant 3. So what pi over 3 is in quadrant 2? So remember, This is pi, which I could also write as 3 pi over 3. So if I back up one and draw it right here with a 3, what would this be?
Second quadrant.
It is. What would it be? What would it be as far as pi over 3's go? 2 pi over 3. And if I also need the one in quadrant 3, I could start at 3 pi over 3 and go forward 1. So what would this one be? 4 pi over 3. All right, so then they want us to figure out which of these match those. So put those in your calculator real quick. 2 pi divided by 3, and tell me which one of the x's up there is it match.
X2.
All right, so 2 pi over 3 is x2. What about 4 pi over 3?
X3.
Okay. So we just found the exact answers for these two solutions right here, x2 and x3. So they're asking, how can I find all of the others? So let's go 4 and 5 first. If I have these two, what would be the easiest way to find out what these two would be?
Let's see.
So if I know these, how can I find those two the easiest way? Yeah, so we need a relationship.
Would it be double?
So it would be, well, almost. When we're talking about these things, we need to know when it repeats itself, right? I found a going below the line and a coming out of the line. So I need the next going below the line and the next coming out of the line. What do we call it when it repeats itself?
Period.
A period. I need the period. Anybody remember what the period of cosine is? 2 pi. So if I take x2 and x3 and just add 2 pi, that'll get me the next two solutions. So
She knows what she's talking about.
I would hope so.
what about if I want to get x1? So x1 is a coming out of the water. So that's related to x3. So how would I get x1 from x3?
Subtract 2 pi.
Subtract 2 pi.
Yeah.
Speak up.
Was you still talking when I said
Calm
these?
down. Why is this side so hostile?
All right.
It really is.
On F, so we found all of the ones,
Then you-
we figured out how to find all of these, but like we were saying before, this goes on forever. So F is asking, how can I generalize it to find all of them? So just tell me, what would I do to find, if I find 4 and 5, what do I do to find 6 and 7?
Do the same thing.
Do the same thing again, add 2 pi. And to find 8 and 9,
Do the same thing.
do the same thing, add 2 pi. And you just add 2 pi over and over and over again. Mathematically, when we have repeated addition, what is that?
Multiplication.
Multiplication. So we're going to add 2 pi n. That n is going to represent however many times we want to go
So
around.
multiply 2 pi by.
Multiply 2 pi by 3, and that means we're going to get 3 sets of answers. Multiply by, or we're going to get the third set of answers. Multiply by 5. Just however many times you need. That's what the n is going to represent. Okay, so the solution could be written as x equals 2 pi over 3 plus 2 pi n. That's what this is. Or it could be written as negative 2 pi over 3. Because right up here, this is positive 2 pi over 3. And this one right here is negative 2 pi over 3 plus 2 pi n. So I could start with those two. And I could add 2 pi n, add 2 pi n, add 2 pi n. So if you think back, this is where all of the things that we've been doing for like the past 9 weeks all start to come together. So if you think back to when we first started solving using our calculator, and they would give us a value and we would do inverse cosine and we would solve and it would give us a solution, But that wouldn't be the only solution. Remember, you had to find another one. And I gave you guys little charts that told you, okay, well, if it's cosine, this is what you do to find the other solution. If it's sine, this is what you do to find the other solution. This is that now. So cosine was the easy one. You find one solution, then you can make that solution negative, and then add 360 over and over. That's when we were in degrees. Now instead of adding 360, we're adding 2 pi, because that's the same thing as 360. So it'll all start to click and make sense in a little bit, maybe. Definitely by tomorrow. Okay, we're going to solve this one. So again, the goal of solving just means get x by itself. So I have 2 sine x equals square root 2. So what am I going to do first?
Wait.
Squares.
You said
Hey, before that.
Inverse square, inverse sine.
How about we divide by 2?
Yeah, Kaden, we don't want it. God, so annoying. Just kidding. Okay.
All right, so now I have sine x equals square root of 2 over 2. I need to get x by itself. Now I'm going to arc sine, or inverse sine.
Authority is disgusting. I can't stand
The feeling is doing
Lily, where do you?
it. Shut up, Shay. Just like Kaden.
Okay, reference angle for where sine is equal to square root of 2 over 2. So I'm using my left hand trick.
Gotta say that.
The numerator tells me how many fingers I'm looking for.
It is your bad.
The value tells me whether I'm looking on top or on bottom. Sine is y, which means I'm looking on bottom. I need 2 fingers on bottom, which means I've got to fold in this finger so that I have 2 on bottom and 2 on top.
I don't know.
That's my pi over 4 finger. In what quadrants is sine positive? 1 and 2. So pi over 4 is in quadrant 1. What's the pi over 4 that's in quadrant 2? 3 pi over 4.
Oh, what's Kaden?
This is sine. What is the period of sine?
Minus 2.
2 pi.
Yeah. I knew all the time.
So we're going to find all of the other solutions. We're going to add 2 pi. So we can generalize our solutions like this. X equals pi over 4 plus 2 pi n. And x equals 3 pi over 4 plus 2 pi n. Okay. So how are the 2 solutions found using the inverse sign related by pi? Look at D. That's what they're asking. These 2 that I found, pi over 4 and 3 pi over 4, how are those 2 things related?
They're the same reference angle.
They are the same reference angle, which means they have a common denominator. What would happen if I added them together?
It'd be 1.
It would be 1 whole pi. Pi over 4 plus 3 pi over 4 equals pi. That's what they're asking. How are the 2 solutions found? There are 2 solutions, but they also total to pi. That means they're supplementary.
That'd be 4 pi over 4.
Yep.
That dumb. Why would we do that anyway?
Now, if you remember the rules, when we were trying to find our solutions, we would put sine, arc sine, or inverse sine in the calculator. It would give us one angle. To get the other one, you would do 180 minus pi. That's because they're supplementary. Or 180 minus the angle it gave you.
Yes.
That's the rule for sine. Okay. Solving this one, I need to get x by itself, and right now I have negative 3 tan x equals square root 3. What should I do first? Divide by 3. Go ahead and divide by negative 3. So and then arc tangent. All right, so I'm I'm looking for where tangent equals square root of 3 over 3. The tangent ones are a lot harder to do with the left hand trick, so my suggestion is that you just memorize the 3 tangent ones. Because it's just easier. Tangent is square root of 3 over 3 at pi over 6.
Should speak all the
I put them all in boxes.
But this is negative square root of 3 over 3, so where's tangent negative? What 2 quadrants? 2 and 2 and 4. All right, so what is the pi over 6 that's in quadrant 2? Yep, 5 pi over 6. And then what would the one that's in quadrant 4 be? Yep. All right, so again, we need to add the period. What is the period for tangent? It is pi.
Oh, yeah.
It's pi, she says.
Thank you, Charlotte Thomas.
So our 2 solutions would be 5 pi over 6 plus pi n and 11 pi over 6 plus pi n. On G it asks, do you need both solutions in order to represent the infinite solutions? Explain your reasoning. So think about yesterday when we were doing the trigonometric technology thing, and you got to the one that was tangent. You didn't have 2 different relationships because tangent never goes like back down, right? It comes out, and it comes out again, and it comes out again. So do you really need 2 solutions that you're going to add? You don't need 2, because you only have 1 relationship. It's coming out of the water, and then it's going to come out of the water again after your period. So you don't need both of them, because the solutions don't come in pairs. So I have 2 of them in F, but if you look, if I add pi n to 5 pi over 6, so if I add pi, that would be 6 pi over 6, and if I add that, I end up at 11 pi over 6. So just 1 solution for tangent is enough. Now this chart in the middle explains the rules. So this is the equation. If you have cosine x and we do arc cosine, it's going to give us a solution. And you only have to find 1 of the solutions. Then this tells you how to generalize. For cosine, you can make the solution positive and negative and add 2 pi n. For sine, you do arc sine, you find a solution and you add 2 pi n. And then you have to do pi minus that solution and add 2 pi n to it. That's how you're going to get your pairs for sine. And then for tangent, you only need 1 solution and you add pi n. Are y'all good so far? All right, so we're going to solve A. What do I do first? Divide by 2. Then I'm going to arc cosine, which means I am looking for where cosine is going to equal square root of 3 over 2. The number on top tells me how many fingers, and the trig ratio tells me which fingers I'm looking at. Cosine is x, which means I'm looking at my top fingers, and I need 3 of them. 1, 2, 3. Fold that in. That is pi over 6. But it's negative, and pi over 6 is positive. I need to know where cosine is negative. It's negative in quadrants 2 and 3. So what's the pi over 6 that's in quadrant 2? 5 pi over 6. And according to this chart, I only need 1 solution, and then I can just make it positive and negative and add 2 pi n. That's it. On B, I don't have to do anything before I arctangent. So I need to know where tangent is equal to 1. Remember, tangent is y over x, so this is why I would just memorize the tangents personally, but because they're really harder to do on your fingers with the left-hand trick. But if any fraction is 1, that number, it has to be a number over itself. And the only place on my fingers that would happen is right here, because that would leave me 2 fingers on bottom and 2 fingers on top. That'd be y over x. So tangent is 1 at pi over 4. And for tangent, I only need one solution, and I add pi in. On C, I'm going to divide by -1, and then arctangent. So I'm looking for where tangent is negative square root of 3. Anybody know where tangent is square root of 3? So this is how I just remember tangent of 3, tangent pi over 3 square root of 3, pi over 3 square root of 3. So it's at pi over 3 is where it's square root of 3. So I need the negative pi over 3s though. So tangent is negative in quadrant 2. So I need the pi over 3 that's in quadrant 2.
That's 2 pi over 3.
Yep. 2 pi over 3 plus pi n. Okay, take a second and see if you can do D.
Sure.
I'm looking for where sine is negative 1/2. So sine tells me it's my y fingers, so that's my bottom fingers, and the number on top tells me I need 1 finger. So I fold that in. So that's pi 6. But sine is negative in quadrants 3 and 4. So I need the pi 6 that's in quadrant 3.
7 pi over 6.
Good. So x is 7 pi over 6 plus 2 pi n. That's my first solution. To get my second solution, I have to do pi minus the solution. So that would be pi minus 7 pi over 6. Well, if I got a common denominator, that'd be 6 pi over 6 minus 7 pi over 6, which is negative 1 pi over 6 plus 2 pi n. That's your other solution. But if you had just gotten the other value in quadrant 4, that's 11 pi over 6. And 11 pi over 6 and negative 1 pi over 6 are the same thing because they're coterminal. So either one of those will work. Doesn't matter. I'll do it that way. All right, where is cosine where does cosine equal square root of 2 over 2? Pi over 4. And cosine is the easy one. You just make it positive and negative, and add 2 pi n.
You creating the positive, negative.
Yeah.
Wait, is that on every single one?
On cosine. Cosine's the only one that does that. All right. Last one on this page. If I divide by negative 2, I get sine x equals 1. All right. So first of all, I know before I ever even go into the arc signing thing, this is a little bit different because it's not a fraction, which means it is not one of my 3 fingers. It's not 6, 4, or 3. It's a quadrantal angle. That means it's on the axis somewhere. So I have to do arc sine of 1. So where does sine equal 1? Sine is your y value, remember. Where does your y value equal 1? 90 degrees, or pi over 2. So x equals pi over 2 plus 2 pi n. And then the rule for sine to get the other value is I'm going to take my solution that I got, I'm going to do pi minus the solution I got. So pi minus half pi. What does pi minus half pi give you? Half pi again, so I don't have to put 2 solutions for this one. That it only comes out that way because it's a quadrantal angle. All of the others you would end up getting another solution, but quadrantal angles don't work like that. They work a little bit differently. All right, are y'all sort of kind of okay a little bit?